volume and total number of particles remain constant, and if the temperature increases, the pressure will also increase.
Okay. All right, so let's take a look at that. This page is very important. This exact page is on the exam. Okay? The exact page. All right, so we've got temperature, we've got mass, we've got volume, we've got average PE, we've got speed, we've got number of particles, right? We've got collisions per second per area. We've got oomph,
I did have increase and she said
and
no,
we've
so it must
got
be something else.
pressure, right? What are you going to do when it says, show that if the volume and total number of particles remain constant? What are you going to do right away? That's second.
Constant arrows in.
Okay, what's two were constant?
Volume and
Volume.
number of particles.
And number of particles? You've got two, correct.
Mass.
And the temperature increases,
Pressure.
then the pressure will also increase. Okay? Now, right away, you know these two are going to have to equal a plus. Okay.
At least one of them, right?
At least one of them. At least one of them. When the temperature increases, which three are directly related to the temperature increasing? That are going to be exactly the same.
Kinetic energy
And oomph.
and oomph.
Automatically, if this is up, they're going to go faster. They're going to have more speed,
Temperatures up.
and they're going to have more
speed
oomph.
and oomph.
The only way these particles so far, what we know, are going to have more oomph is if we heat it. There's one other way if they get bigger, but we're not dealing with that in this chapter. If you're cooling it, they're going to have less oomph. If you're heating it, they're going to have more oomph, right? So right away now you've got all these done. So easy. The mass. Did it say anything about adding particles? So what has to go here? It's constant. Right? Collisions per second per area. Think of it this way. If you have a bunch of kids that are just waking up and walking around your classroom, or a bunch of kids that just ate tons of sugar in your classroom, where's there going to be more collisions per second per area?
Sugar.
The sugar. So the heating or making it faster, what is that going to do to the collisions?
Increase.
It's going to increase. Now you look, do these three make sense? Does that make sense? That if that increased, that increased, that would increase?
Okay.
Then you know,
Collision
okay,
speed,
I've
oomph.
got that. Okay?
So wouldn't collisions per second per area be directly related to the temperature?
Not necessarily,
Because if
because
you change the volume.
if it's a movable container, then it's going to be different.
Temperature and volume are the most two important ones, because if you have temperature, all these other ones are going to increase. If you have volume with temperature, but you're increasing it at the same time, you've got that extra space, just like the balloon. If the balloon is expanding.
Good explanation. Okay. All right, so let's look at the second one then. Now remember, these ones are very important. I'm telling you, they're on the exam. Question number 4, you have two choices. You can do the first question number 4, or you can do the second question number 4, which is exactly these. Okay? So if you want to do the first question number 4, you can do that, or you can do exactly these if you feel like you understand these. Okay, so you have two choices on the exam on question 4. Okay? All right, now look at S2. Who wants to come up here for S2? So we got the same things. We got temperature, mass, volume, kinetic energy, number of particles, collision per second per area. Oops. Was it even a little bit easier doing it that time than when you did it for the homework? Okay. All right, who wants to come up and? All right, come on up.
I'll do it. I just don't have my book on me, so you guys tell me what we let's do.
Okay. So who will read it? Okay, go
Fill
ahead.
in the macro micro table to show that if the pressure and total number of particles remain constant, and if the temperature increases, then the volume must also increase.
And then it was pressure in what house? Remains constant?
Number of particles.
So temperature's going up, kinetic energy has to go up. The number of particles is constant, so the mass has to be constant.
Those two are related, right? They're always going to be the same.
What are
Right.
mass and
Good.
And when I remembered, I made myself like a diagram from the last few homeworks ago, when we were just dealing with like the CSA and the oomph. That oomph can't increase unless speed increases, and speed only increases with heat. Which I'm pretty sure is right? So if the temperature is rising, then that means the speed and the oomph have to. And then you plug it into that pressure model that you have. So it's the pressure, so if the oomph is increasing and the pressure is increasing,
Pressure is the same.
pressure's the same.
Here's the pressure.
So then this has to be constant.
No.
That has to be
balance out.
decreasing.
Has to be decreasing.
So only one person in the class got that one.
I was gonna say.
That was the hardest one.
I got that wrong for sure, okay.
That's the one I got wrong.
Negative
right there.
1 plus 1, 0.
Yep. So think of
Okay,
it.
so when they're opposite.
So it's the balloon.
that's what it is.
The only way those you get those.
Okay, negative 1 plus 1, 0. Does that make sense?
How do you figure that out?
You're increasing the volume.
Based on the
So they
mass?
have, there's more.
No.
Around.
And then CSA.
Because the pressure's constant?
Uh-huh.
Volumes increase.
We already know the oomph increases because the
Which
temperature's increasing.
Right.
The CSA.
And because the number of collisions and the oomph
Ah,
have to balance out to
volume is
pressure.
increasing, but the same number
So
of
you're
particles.
increasing the one.
And
This
decreasing
is
other.
So the
constant, so that one
collisions
has to
will
go down.
go down.
Gotcha.
Okay.
So those
Okay.
last three are sort of
Now, I
related.
want you to try number 3
I
all
always
by
like circle.
yourself.
Yeah, that's what
All
I
by
did.
yourself.
It helps.
Wrong then.
Try number 3 all by yourself.
What were
If you
the-
don't have your book,
The constant, sorry.
if the volume and temperature remain constant,
Okay,
total number of particles increases,
okay,
pressure must also increase.
okay.
The mass increases. And the kinetic energy, speed, stay constant.
Volume and temperature constant, particles increases, pressure must increase. Volume and temperature constant. Temperature constant means what else is constant? Automatically.
Kinetic energy.
Kinetic energy, speed, and
It's constant because temperature.
oomph.
Yeah.
Kinetic energy, speed, and oomph, automatically going to be constant. Number of particles increases. What else is going to increase because the particles, you put more particles in?
Mass.
The pressure must also increase. Okay. So what do you have for temp?
Constant.
Constant mass,
Increase.
volume,
Constant.
kinetic energy,
Constant.
speed,
Constant.
particles,
Increase.
collisions,
Increase.
oomph,
Increase.
pressure.
Increase.
Does the constant increase make sense at the end? Do those last 3, if you were using an equation of plus 1, 0, minus 1, did that make sense? You have a plus 1 and a 0 and a plus 1.
So
So
adding more
if the number
sardines
of
to the
particles
can.
increases, the number of collisions
It's
per
in-
area per second will also increase?
Because you're plugged in this
If
thing,
the
you're
volume
trying
stays
to
the
get more
same.
sardines
Okay,
in.
as long as.
If the volume stays the
It'll
same.
increase.
Because you're putting 40 kids into the room instead of just 20 kids into the room. So will you stop that once in a while, Chelsea, because YouTube will only take
Do I push the
15
red-
minutes.
the red
Pardon?
button?
Red button, yeah.